Alright, so now that you were entertained by that video of Little Big League and the math problem, let's go ahead and take it down. Let's make sure we understand what we're seeing, talk about what we're seeing, and then in the process develop a formula for a rate of work. So in the word problem that we saw, we have two people working together to paint a house, right? We had Joe, who can do it in 3 hours by himself, and Sam, who can do it in 5 hours. And the question was, how much time would it take them to do together? And we saw a lot of various answers, so let's talk about that. One person said, well, why don't we just do 5 times 3 and get 15, right? Another one said, well, why don't we just add them together and get 8? Another one said, well, why don't we average them and get an answer of 4? Okay, and what I liked about that is that's typical what happens for most of us when we're beginning word problems. We just kind of start random ideas without really making sense of them. We just, we add, subtract, multiply, divide, and without any real rhyme or reason. You notice that's exactly what those gentlemen were doing as they were doing that problem. So let's think about what they said. All right, so we already know that Joe can do the job all by himself in 3 hours. So if somebody's going to be helping him, right, then the time together should be less than 3 hours. All right, that's assuming, again, they're painting a house and they're not sitting around drinking beer or something goofy like that. But for sure, right, if they're just concentrating on the work, if Joe can do it all by himself in 3 and Sam's going to come along and help him a little bit, then together this time should be shorter. And that's what fails on all these, right? 15 is a lot longer. Again, that's probably where they're just sitting around drinking beer and having a good time, right? 8, also the same thing, right? That doesn't make sense. It's not that. And then even the average doesn't make sense. The 4 hours is less than Sam, but my time should be less than Joe together, right? Since Joe can do it in 3 hours. So that's why those things, even though it's okay to kind of, dare I say the word crapshoot, right? And that's all right to do in a problem, right? You're just kind of throwing ideas around, but think about the answer that you get in the end, and does it make real life sense? And you didn't see any of those guys doing that. And then we had a guy come up and, pretty much create, he said a formula, and it's really not a formula. He just put some numbers together. He multiplied the 5 and the 3, and he added, and he didn't show that part, getting us 15 over 8. And that is basically the mixed number 1 over 7/8. So the good news about his answer is it does satisfy what we're talking about, right? 1 7/8 hours is actually less than Joe's. So that makes it a little bit more right than that. But how did he get that is the question. So here's what we're going to do. It turns out that when we have a time when I can do a job, then the rate of work, right, is going to be 1 divided by that time. And so we're basically saying it's going to take one job 3 hours to do. So basically together, this 1/3 is Joe finishes 1/3 of the job in 1 hour. That's basically what that 1/3 represents. So one job's completed in 3 hours. So in 1 hour, how much work will Joe complete? Well, he'll have 1/3 of the house done. And it turns out that Sam's the same thing, right? It took him 5 hours, so what's his rate of work? Well, it's 1 over 5. So basically, he's going to have 1/5 of the job done in 1 hour of time. And if we keep going with this, right, if we want them to work together, that means that we have to add their rates of work. So in 1 hour, right, again, we're establishing in 1 hour. In 1 hour, Joe is going to have 1/3 of the job done, and Sam is going to have 1/5 of the job done. And so this would represent the time that it takes to work together. All right? However, let's go back here, right? The time together, right, we don't know what that is. So in classic math form, what we do is we represent that with a variable. So capital T represents the time that it takes together. So what's the rate of work? Well, if we keep following this example, it's one job per T hours. So here's the rate of work when they're together. So at this time, I have 2 different ways to represent how much of the job's done in 1 hour, right? The variable way, 1 over T, and this fraction way, 1/3 plus 1/5. So since these two represent the same thing, that means we have an equality there. So let me rewrite it here. So we have 1/3 plus 1/5 is equal to 1 over t. And that's basically a classic rate of work formula. But let's just go ahead and solve this. How do we solve something like this? Well, earlier in chapter 6, the idea was we find an LCD, which is 15, and we take that 15 and we multiply it to both sides. All right, distributing here, what we end up getting is 5 plus, and that'll be, oops, you know what? I messed up. 5t is going to be, I was thinking something was wrong. So if we look at all our denominators, right, 3 and 5 go into 15, and then there's this t. So I'm sorry about that. The LCD is 15t. So if I multiply it both sides, we get 5t plus 3t equals 15, because the t's will cancel out here. Combining like terms, we get 8t equals 15, and if we divide both sides by 8, we, lo and behold, get the answer that the guy got in the video. All right, but there's math actually supporting it. It's just not this strange formula that nobody understands. There's actually a method to the madness. So our formula, if you kind of follow that work along, right, it's going to be basically 1 over the individual time for one person plus 1 over the individual time for another person equals 1 over the total time, right? And so again, I1 and I2 represent individual times of the workers. 1 over I1 and 1 over I2 represents their rate of work per hour. And then it's going to be equal to 1 over T, where T is the total time. If there was a third worker, we would just add their rate of work. If there was somebody like when we're cleaning the house, my wife and I are trying to clean the house, and usually our kids are dirtying the house. So our rate of work would be adding to the job. Our kids' rate of work would be subtracting from the job. So you can keep playing around with that formula. And so there is basically our formula that we can use to solve rate of work problems. So 1 over individual time plus 1 over individual time, you keep adding those, equals 1 over the total time together. And so now that we have a formula, now let's go do some word problems where we can handle them.